Hey guys, how's it going and welcome back. Today we're going to test a couple of Sabrent cases. They're actually both the exact same case, except they have different drives. The one case has a Western Digital SN570 3500 by 3000 drive in it, and the other case that I just got in today, which is what that box was from, that case actually has a half a terabyte. We don't know what drive. It says Intel on it. It's got the sticker over the top, the heat shield, so I don't know exactly the brand, but I do know that it's 3000 megabit per second read-write speed. It came out of my ASUS Top 17 gamer laptop. So we're going to do a speed test. I talked to you guys a lot about, out of a Thunderbolt port or Type-C port, you're only getting 900 milliamps. These drives tend to want well over 2 amps, which is a reason why they run slower, they run hotter. If we could get powered cases, we could actually gain some speed. Not a whole ton, mind you, but we would gain some speed, and our drives would run much cooler, and of course, lifespan-wise, they would last a lot longer because they wouldn't run so hot under heavy loads, because heat does destroy things. So we are going to do Blackmagic speed test, but we're going to do that as an on-screen thing. But over here on top of my Mac Mini, I don't know how well you can see that, but I'm going to zoom in quickly for you so you can see the cases in question, hopefully. So these are the two cases side by side. This drive contains the 512. This one is a 1 terabyte. So, and anyways, so let's cut off the camera. Let's go to the computer so that you can see exactly what's going on with these drives. Here on Blackmagic, design this speed test. This does actually report a little bit slower speeds than what Crystal Disk would. So you're generally looking at around approximately 1000 megabits per second generally, okay? And so first we're going to test out, and I'm just going to quickly quit the program and restart it. My internal Mac Mini drive, this is an M1 Mac Mini. And we're looking at 3036.5 read and 2827.8 write speed, which is actually pretty quick. That's some really good speeds, and we look at our chart for the different types of video formats and everything. We got check marks everywhere. We're good to rock on everything. Okay, and we are also using what's called a 5 gigabyte stress test. So we're making the drive work, okay? Most people even testing with Crystal Disk are actually only on a 1 gigabit test. They are not actually going to higher levels. And that does make a little bit of a difference in speed on how we see how drives react. But we want to put it under a heavy load because mostly what we're doing is heavy load stuff. So this is a more realistic synthetic test is when you can put it under a much heavier load. And I have pushed Crystal Disk to its limits, and yeah, it's quite the difference when you really make it work. So anyways, let's go to select drive here. And we're going to start with the HD 1 terabyte. Now this is going to be the 3500 by 3000 Western Digital SN570 drive, and we're going to test its speed. And this is direct. Both drives are hooked direct to my Thunderbolt ports on the back. And they are Type-C to Type-C connections. So that's not too bad. Let's just rerun the test again. I didn't quite get it quick enough to shut the switch off in time. And we'll just let the test run again. The test numbers do vary as you're stressing the drive. So basically we've got an 809.9 by 800 let's call it an 800 average, okay? And we've only got a couple of X's. That's not too bad. Now for the 512, in the exact same case, but it's a 512 and slightly lower speed rating. So we'll select our drive, 512, and click open. We'll let the test run a couple of times. Now both cases do have that silicon heat tape stuff. Whether it physically touches the drives, nobody actually knows because we can't see inside the case. And we'll go one more round. This drive is actually doing a little bit better. So we've got about 853.7 to 816. So just over 800 megabits per second average read and write coming out of the 512. So now that the other drives had a chance to cool a little bit, let's try it again. So we've got an 830.5. 849. And one more. Okay, so overall, we're seeing similar results, right? So now the other one's had a chance to cool. Let's rerun it. Numbers should stay relatively consistent. In the real world, though, we do see different numbers from what a synthetic benchmark does. This is why I don't always rely on synthetic benchmarks, but it does give us a really good idea, at least, of the kind of performance we can expect, which is not what we're actually paying for. You know, we're paying for more, but we're getting far less. And you got to kind of wonder why. Well, that's a pretty simple answer. Regardless of anything else, we're not seeing the speeds because, number one, these drives just run hot even doing nothing, okay? Just sitting there mounted on your desktop, they're running hot. You're only getting 900 milliamps of power out of the Thunderbolt port or Type-C port. These drives want over 2 amps to themselves, realistically, okay? They're not getting it. They're being starved for power. When you starve something for power, it doesn't shine as bright. Kind of like a light bulb and a dimmer switch. I've talked about this. When we turn the switch down lower, as we lower the power to the bulb, the light bulb started out at 100 watts. Well, at half of it, it's 50 watts. And we have less voltage. Now, in the case of this, our voltage is a constant. It never changes. We always get 5 volts out of Type-C, Type-A, doesn't matter. It's all 5 volt, right? The drives actually only run on about a little over 3 volts. So that's all they need to get, and that's all the controller allows for power to go through is what the drive needs for voltage. But what it can't do is allow the amperage to be what the drive wants, because it only gives 900, and that's all the controller can access, and that's all it can give to the drive is the 900 milliamps, which is actually less than half of what it requires to run properly. and to run much cooler too. And we would be able to sustain much higher speeds if we had proper amperage going to these cases. And I have not yet found any type C type cases that are powered. I found a couple of Thunderbolt ones, but they're very, very expensive. Okay, so really idealistically, we're paying all of this money for what we assume is going to be a fast drive. Now internally, if you put these drives internal into computers that support M.2 or what have you, then yes, they're going to run extremely screaming fast speeds. So in that case, you are getting what you're paying for if you're going internal. Unfortunately, on the M1s, and actually every Mac since about late 2015, we've not been able to upgrade drives anymore inside. And of course, we never had the M.2 technology. We had Apple's weird stuff. And but otherwise, we've had to go with external drives. And with M1 and M2 technology, of course, everything's built onto the SoC. There are no NVMe slots. So for Mac users, your only real solution is if you want the speed that you're actually paying for, or at least close to that speed, you have kind of like two options. You go with a really good high performance Thunderbolt case. Even though these are not PCIe 4, they are compatible. Doesn't matter because even 4 goes backwards to 3. But you just need to buy PCI 3 drives, or maybe a combo 3.3 and 4, and you go into an external Thunderbolt case that actually has been proven by many YouTubers and reviewers, period, that it can attain at least over 2,000 megabits per second. Okay, now a cases does have a drive case that can achieve really, really good speeds, like very close to your 35 by 3. It's more like, it's just slightly under 3,000 megabits per second. That's about the closest you're going to get in a non-powered Thunderbolt case on average. Okay, when you go to a powered Thunderbolt case, you will get more speeds like 4,000s and maybe 5,000s with a powered case. That's totally normal and pretty much about the max that an external Thunderbolt can actually provide being powered. And by being powered, it's going to give you that up to 40 megabits transfer rates. And of course, your drive is going to get the amperage it requires because it's a powered case. It's going to be able to supply proper amperage to the drive to run it out faster. And that really is the big difference between a powered and a non-powered Thunderbolt case, is as far as how the speeds are going to actually behave. One case gets 900 milliamps, and your speeds are going to be whatever they happen to be. And then, of course, the Thunderbolt case that's powered with the same exact drive in it is going to achieve much, much higher speeds. So, and if you want to go beyond that, then you go internally. So you don't have to, well, actually, I wouldn't even recommend buying a 7,000 megabit plus per second NVMe drive if you're going external, because you're never going to achieve those speeds, like not in this lifetime. Well, at least not with present technology, at least anyhow. But internally you will, but you have to have a computer that will do that. And unfortunately, that's only going to be the PCs that are going to be able to achieve that internal speed, other than anything that, say, Apple puts out that already has speeds that are like that already in their built-in SoCs, then yes, that case, yes. But we're talking about physically purchasing a drive, purchasing a case for that said drive. You know, for external use, that's what we're going to get. Internal use, you purchase an NVMe drive internally only for PCs because Macs can't use them. Apple has their own thing. Apple does have some extremely, extremely fast drives in some of their Macs, but that's what you get from Apple. And you're going to pay a premium, okay, for Apple internal storage no matter what, which is why a lot of people go external, but external, to get those really super fast speeds that are going to be practical and getting what you're paying for as well, you definitely should be looking more toward a powered Thunderbolt case and not an unpowered. Because the unpowered cases, regardless, they may go faster, yes, than Type-C. Totally agree with that. I will not say any different. But if you want the longevity out of that drive, you want the performance out of that drive and the cooler temperatures, you must go with a powered external Thunderbolt case to do that. And then this way, at least the money you spend, you may not be getting the full potential of that drive, but you can get really darn close to it. In the lower speed drives, but in the higher speed drives, you're going to get probably about 4,000 to 5,000 megabits per second. But if you bought something that was already 7,000 megabits per second, that's a huge loss to take. I probably would say, maybe go to the lower side of the fence, something that is about 3,500 or maybe even 4,000 megabits per second, because then you're going to get more realistic that way, and you're going to be actually getting your money's worth in that sense. And there are Thunderbolt cases out there that are unpowered that can go quite fast. You just got to do a lot of research and hunting them down to find the right one. And that means watching a lot of YouTube reviews on cases, finding out what drives people are using in said cases as well, because that's going to change from, channel to channel, because not everybody likes the exact same drives. Some of us prefer others. I'm kind of a Kingston and Western Digital fanatic. I do not like Samsung, but I do also like Crucial drives. They're pretty good. And even different brands may have their ratings, but some of their ratings are actually really not there, where others are exceeding or they're right on those speeds. And this is where you need to do your homework seriously when you're looking at drives. Anyways, that's what I got for you guys today. Now, if you're curious about one other thing, which I'm sure you were, and then we're out of here, my 1 terabyte NVMe that has the little apple on there, that little guy is sitting on a powered hub that's like 3.2, and it's a Type C to Type C connection for the drive itself. And it is running off a Type C to Type A converter because of the hub. It's a Type A only hub. So I thought, well, why not show you guys that thing and what we're getting out of that. Now, this drive normally will run about the same exact speeds as the other two, but this is how it would run when it's converted to Type A 3.2, okay? And the hub is powered, but the drive is not. And I'm only getting 900 milliamps out to the drive. Now this is a drive that's rated for a little over 1100 megabits per second. So, and I do see very close to like 800 out of it easily. I get the 800s, but I'm never going to get anywhere close to what it's rated for. And neither will you externally. It's going to run the same on a Mac or a PC. It's just that PC might show closer to that 1000 than what this speed does on the Mac. But this is what you can expect with a Type C drive of over 1000 megabits per second being on 900 milliamps of juice with a Type A converter in the way. So not the most impressive speeds, but that's not quite 3 times slower than a Type C to Type C full connection. So yeah, that's kind of interesting how Type A can really slug things down. So there you go. But still plenty of fast to do a lot of video editing, It'll definitely handle 2160p. It'll handle 4320 right across there at 25 frames per second. It'll even handle some of the 8K stuff at 24 and 60. So that's still not bad. Not the greatest thing on the block, mind you, but that's where it's at. But that drive has to be on there because, yeah, I got a lot of stuff hooked up to my Mac. But, anyway. So that's what I got for you guys on this one. So that's 2 Sabrent cases, exactly the same cases. So it's a very fair competition that they're identical. The difference is the drives, who makes the drives, and there's about a 500 megabit slower difference on the one that came out of my Asus over the Western Digital that I bought from Best Buy. And these are the speeds that we can expect to see in this kind of setup. So anyway, that's it. That's all. Thanks for watching. I hope you enjoyed the video, and we'll definitely catch you guys on the next one. See ya.